So again, $13 an hour tutoring, $5 an hour as a teacher's aide. Let X be the number of hours each week spent tutoring, and Y is the number of hours spent each week as a teacher's aide. Complete parts A through E. So they first want you to write the objective function. I sometimes will call this the profit function. If the student tutors X hours a week, then the money by tutoring X hours a week is 13 times X. And then the student spends time as a teacher's aide, and she does teacher's aide Y hours a week, so earning $5 an hour, so 5Y. Objective function, Z equals 13X plus 5Y. They have typed the Z for you. You don't type that. Part B, the student is bound by 3 constraints. Write an inequality for each. Well, the student has to have enough time for studies. This student can work no more than 19 hours per week. The total number of hours worked would be X plus Y. All right, total hours worked is X plus Y. And so my inequality for this, X plus Y is less than or equal to 19. Student can work 3 hours a week, or 6, or 19. Student cannot work 22 hours a week. The tutoring center has some restrictions. Each tutor has to spend at least 4 hours a week tutoring. So tutoring is X, so I will write X is greater than or equal to 4. At least 4, they can tutor more than 4, but look at number 3. The tutoring center requires that each tutor spend no more than 8 hours a week tutoring. So X is also less than or equal to 8. From here, I will graph my inequalities. We're going to graph these 3 inequalities. I'll show my work on the side. X plus Y, let me write graph. X plus Y is less than or equal to 19. So I need to graph first X plus Y equals 19. Will this line be solid or dashed? Solid, because a student can work 19 hours. And I will pick the intercepts. If I plug in 0 for Y, well, I'm going to get 19 for X. And if I plug in 0 for X, I will get 19 for Y. So on the graph, I will select the straight line, the solid line. I will secure my line at 19 on Y, and then I will go to 19 on X, secure those 2 points. That'll put the line in for you. I'm going to put it here with my straight edge. That's the total line represents the total number of hours student can work. The student can work less than that, so I'm going to shade less than that. Now, I'm shading even negative numbers, but can the student work a negative number of hours? No. So we really just need to be in the first quadrant. And really at this point, we probably wouldn't shade yet on the computer. We'll just do that at the end. If I'm working it out by hand, I can kind of shade the in-between steps. For this, we also need to graph x is greater than or equal to 4. For that graph, we'll do x equals 4. What kind of a line is that? Vertical. And I was almost thinking somebody was going to say solid. It is solid as well. So, vertical line through 4 on the x-axis. I'll put that one in. Select the line tool and secure 2 points where x equals 4 to put in the vertical line. On the shading, greater than or equal to 4, so I would shade to the right of that. But what is another restriction? We also have to graph x is less than or equal to 8. So for that we graph x equals 8, which is what kind of a line? Vertical line. And it's through 8 on the x-axis. So I'll put that in right here. The shading for x is less than or equal to 8 would be to the left of that line. I'll show that with a pencil and kind of go on an opposite way, or put the lines going a different way than I did before. Now, where the 3 shadings overlap, that is the feasible region. I'm going to shade this in orange. This is where you would shade, dump the paint on the computer. In that area right there. So I have it graphed. Look at part D. Evaluate the objective function for the total weekly earnings at each of the 4 vertices. Those are the corner points of the graphed region. They have given me the corner points. So I kind of like this problem because of that. They're just really walking you through this. The corner points are 4, 0, 8, 0, 4, 15, and 8, 11. Let's see, there we go. 8, 11. So with that, I have my objective function, and I'll plug in my corner points. And in fact, well, they want the value at all 4 corner points. So I'm going to rewrite my objective function. Z equals 13x plus 5y. I'll do this in chart form, corner points. And write my objective function in one of the columns. The corner points were 4, 0. You can put them in any order. 8, 0, 4, 15, and 8, 11. So for the first one, I'll plug in 4 for x and 0 for y. Z equals 13 times 4 plus 5 times 0. On my calculator, I'll do 13 times 4, and I get 52. For 8, 0, this would be the student tutored 8 hours, teacher's aide 0 hours. If the student did that, 13 times 8 plus 5 times 0, 13 times 8 is 104. For the corner point 4, 15, the student tutored 4 hours, earned $13 an hour, and the student was teacher's aide for 15 hours, earning $5 an hour. 13 times 4, well, let's make that a 4, plus 5 times 15 is 127. Then the last one, 13 times 8 plus 5 times 11. 13 times 8 plus 5 times 11 is 159. They want you to type in all 4 of those numbers you got from the corner points. So right here for part D, I'll put in 52, 104, then 127, 159. You do not have to put those in any particular order. For part E, complete the missing portion of the statement. The student can earn the maximum amount per week by tutoring for 8 hours and teacher's aide for 11 hours. The maximum amount the student can earn is $159 a week.